Hey guys, welcome back to the channel. Today in this video, pretty much like the last one, we will look at how to make generators for idle games. How to make them the most basic way possible, the beginner way to make generators. And then we will see how we can flesh it out and how to connect it to other parts of the game and how we can get it to communicate and have upgrades, things like this. In the same time, I already can tell you that for this video, we will be taking a node from Godot, which is the timer node, and we will, sort of improve this node so that it allows us to do more things than what it does currently. Okay, so we will also learn how to create your own custom nodes, sort of. So let's get started with this blank project by, just as usual, create a generator prototype, which we will save in scenes folder and the generator prototype folder. All right, so we do have something to play with. We will create two main things that we need. We need a label to show the amount of resources we have generated, and we need a button to control the generator. So generators are kind of on-off things. So we might think of using check buttons instead of big buttons, right? So that's totally up to you. For this, at the moment, we will use a regular big button because that's the most basic way to do it, right? So let's use the button. So yeah, let's position these things a little bit so that the label is going to be on the top with, as usual, 80 pixels. 8, and center alignment. Also, this theme will be a variation header large. All right. As for the button, we will put it at the center with 320, 80 pixels, and that's it. Just generate. At the moment, I will name it generator. All right. Here, the label, let's give it a simple bold, no value, so that we know we need to give it a value. We can start by creating a script for this scene and do everything in one script, just like the last time, right? So create this script, which is going to be prototype generator, and create a variable bold as an int, which starts at 0. We will get also the label, so that will be the label typed label, which will be defined by the editor right now. It's assigned. We need two functions. We need the update label method, as usual, right? You want to update the label every time the gold is going up, and you just want the label text to be equal to gold with a string value of gold. We also need a method which is going to be generate gold. This method will only do, well, it will do two things. It will add one gold to the current amount and ask for a label update. Like this. I guess we have everything we need. Almost. So generators, they can work in different ways. You can either use a timer node. That's a great way to make very simple generators. Or you can make your own behaviors by using the process method that runs every frame, and has a delta argument. Right now we will begin by using the timer node. So we will create a new node, which is timer node. We don't want this to be a one-shot. We don't want this to auto-start as well. We want this to be activated by the button, basically. So let's create a connection here so that the button, when pressed, does something that activates the timer. So here we will grab the timer through the editor, just as usual. So that will be timer type timer. And once we have the timer, we just, well, at first we will just start it. So we will have timer.start. Let's assign the timer in the inspector like this. The timer is assigned, but how does it trigger generate goal? It doesn't. So there's a signal as well that you can connect to another method, which is going to be generate goal like this. If you want a video on signals, that might come later on the channel, or if there's not, you can find a lot on YouTube. It's very simple. But anyway, yeah, if I do a video, it should appear somewhere at the top right, but I don't know where I'm pointing. So anyway, we have this thing which should work, I guess. If we start this little scene here, we have the button, we have the goal with no value. That's okay. That's okay. We can click the generator, and that starts generating gold every second. Right? So that's the first most simple generator you can do. Now, what we can do is, as we noticed, when we start the game, the label is not updated. So let's update the label before getting ready, right? So now we have gold 0 and we can start generating gold. That's cool. And now let's add a little bit of logic so that when we click on the button, it, instead of just starting the generator, it toggles the generator on off. Okay? So to do this, we will just go check the timer documentation, right? To see what we can work with. We have the start method and the stop method, which are the two methods we will use, right? And we have the is stopped method that tells us, well, returns true if the timer is stopped. That will allow us to know what is the actual state of the generator when we click on the button and what to do, right? So here, let's create a new method, 1, 2, 3, and that's going to be toggle generator. And we will make a simple check, which is if timer is stopped, if the timer is stopped, we want to start it. So we want timer.start. Else, which means the timer is not stopped, then we want to stop the timer like this. All right. So I went away a few minutes, so I can't remember exactly what I was doing, and I think I was about to test the generator to see if we can start it and stop it by clicking again on the button. Well, no, because I didn't rebind this method. Now I know. So it should work. Let's see. We start the generator, have a few gold, and stop it. So now maybe we can try to improve this a little bit more by changing the button and telling the player what's happening. So let's have this How can we do this? So first, if we want to change the button, it's better to just grab a reference to that button. So here we will grab a reference with the editor, like this. And when we toggle the button, where is it? Here. When we toggle the generator, we want to change the text as well. So maybe we can have this update button method in there, so that we have update button here, update button, whoopsie, get it a void, and there we want button dot text to be equal something based on the state of the generator. So maybe we can say if timer dot is stopped. So if the timer is stopped, then we want to say button dot text equal generator off. And else we want to say button dot text equal generator on. Right? And maybe just for the look, I don't know, we can go in the focus of the button and change the mode to none. And try this. So we have generator on and generator off, and we can on off like this. Okay, we just need to update generator when we start the scene. And yeah, I guess that's it. That's a good first generator prototype to have. So again, I will redo the simple steps that I did in the clicker video, because maybe if you're here you didn't check the clicker video. Maybe you didn't. It's fine. Maybe you're interested in the generator, and I understand that. So here, first thing we will do is create a scripts folder to create a data object. Script folder because we do want to delocalize the data out of this generator here, this script here, so that we can work with the data that's common to, not common, is it? Does it work in English? But the same data for every object in the game, right? So we want to do this basically. So we will create a new script, which we will name data. And right there, we just want to have class name data. And we will create a variable gold initialized to 0. So now that we have a data object, we need to initialize it somewhere. So again, we will create a game node and managers. So we'll have managers later on, but at the moment, let's focus on making the game node. So we want to create a gray node, which will be game. Game will be saved in scenes.game, okay, and it will have its own script. Script, which will be game. So here we will make a singleton. So I'm not gonna, I feel like I explain singleton every day. So what I'm going to do is, if you don't really know how to work with singletons in Godot, find, yes, oh geez, find there. So annoying, the mirror thing. To get to a singleton video if there is one, and if there is no singleton video, which is gonna be the case when the video you're watching, the day it will be released, there will be no singleton videos. It will come later. You can go in the clicker guide. You have the full explanation of how this works. You go in the clicker guide and you will be at the same point of making game. You have this. So anyway, let's make the static variable reference type game. And when we enter tree, we want to check if ref. We want to Q3 if there's already a reference. We want to return as well. Otherwise, reference equals self. Good. So now we have a singleton. Now that we have a singleton, we can create a data variable and initialize it directly because it doesn't need heavy computing. So we can use that. So now we have a semi-global data. Semi-global data, so we can get rid of this gold here, like this, and replace all this by game.ref.data.gold. Or actually, let's start by having an already variable data, which will be equal to game.ref.data. So let's see what we have. We have data.go here, and that's it. So we have delocalized data to a game node here. So now we need to run both nodes at the same time. So what I'm going to do is just drag and drop my generator as a child of the game node. And I will set the game node as the main scene of the project. Project settings, get run, and choose game TSCN. There we go. So that I don't start the wrong scenes all the time. So now the goal data is delocalized in the data objects and it works fine. The reason why it is in a data object like this and not just directly in the node is because later on you want to be able to do this, extends resource, and you want to be able to export the variable so that you can save and load it if you use the resource system, which I do. Right. So now maybe we can begin to do a little bit more things to make this generator a little bit better. Maybe we can start with a few upgrades. That could be nice. So if you want to make a few upgrades to your generator, you will need managers. You can use managers for the businesses or just use a manager for the generator. It depends on the complexity of the game. I honestly can't remember if I did 2 managers for the clicker. Maybe not. But here, we will make a generator manager. And we will see if we need a resource manager. So first, let's create a new node, gray node, which is going to be a generator manager. Let's save it. I think we almost have a folder, so now we do. We can save and add a script. Let's type it, manager generator, all right, and create the most basic things you want in a manager, which is, I don't know what signals we will use, but let's have this generate gold. That's for sure. We want to calculate generator power. That's for sure as well. And we do need a variable generator power. So we here generator power. Do we want this to be a float? Now let's keep it int. Let's keep it int like this. So we will also, well, every time, 1, 2, 3, we will start by when we already calculate the generator power all the time. Okay. So here, when we generate gold, we just simply want to, you know, game.ref.data.gold plus equal generator power. All right. And now, actually, I want to see a new signal being gold generated. And here, we want to emit that signal. So gold generated dot emit. And actually, I will give an argument quantity, which is, again, generated power. Whoops. Generated power, like this. And we will specify that we have an argument being an int here. Looks cool. To calculate the generator power, at the moment, we would just have generator power being equal to 1. Okay. So now that we have this generator, we need to, this manager, sorry, we need to add it to the game node, and I will just create a managers node to get this in it for organizing purposes. All right, so we have the generator right there. And actually, I forgot something very important, which is the singleton. We need this to be a singleton. So that's going to be manager generator. And we need an entity. This, so if ref q3 return and ref equals self. All right, so it's a singleton. We have the methods, we have the first signal, and we have the base power. So now we can go back to our prototype and change a few things to use that new handler we have, manager. So what can we do? Here, when we have well, basically we can change this generate gold thing. Right there we can do this manager generator dot ref dot generate gold. So this way we don't need to have the calculation in there anymore. It's gone. So that's cool. But still, there's a lot of, logic being done with the timer and thing. So I guess we will move the timer. But first, let's just check that everything's working fine. We can stop the generator, yes, and we can stop the generator. So yeah, everything's fine at the moment. We can change more things, and those more things being moving that timer in the manager here so that it's not controlled by the interface but by the brain here. So that we will do this. And also what I want to do is I will actually create a gold manager because I do want signals. I want gold signals to exist. So I will create this gold manager as well. So let's start with the gold manager actually. So here, generate a manager, curve folder, gold manager. All right. Let's create a script like this. Let's grab my trusty singleton pattern in there. So that generator can now be goal generator. Oh, goal manager. My brain. Oh, okay. My brain is already dying. That's a very bad sign for the rest of the video. Cool. So now we want, well, we will use only one signal at the moment, and that's going to be bold created with the quantity. All right, so we have this signal. Let's have the variable gold in there as well, like this. So already what we want to do, first thing we want to do is have gold equal to game.red.data.gold. Like this. Maybe because we could be using data a lot. I don't know. No, let's create a new function actually. Let's have this load data function. That's going to be gold equal game.red.data.gold. No, dot gold. Like this. And when we start, we want the manager to load data. And we will have a save data method, which is going to be save data. And that will be game.red.data.gold equal gold. Okay. Now let's create a create gold method with a quantity argument. That's going to be an int. And we want gold to be plus equal quantity and emit the signal gold created. Emit this with the argument quantity. All right. And at the moment, let's just save data every time we create gold. Okay. This goal manager now must be added to our managers list, and we're fine. And we can now go back to the generator manager and work with this timer. So here we do need, we can reference the timer. Let's reference the timer. Yeah, let's do this. So we will have an export variable timer, which will be manually set from the editor. So timer is going to be equal to timer. Okay. And we will create a toggle generator method, toggle generator, like this. And that will be the exact same method as this one, really. If timer is stopped, you want to start, etc., etc. So let's have these lines copied and pasted. So here we toggle the generator. So we can get rid of this basically. Now on button pressed, maybe we want to use the manager generator dot ref and we want to toggle the generator. So because of that, we can basically get rid of generate gold as well. Because now the manager will be responsible for it. We can get rid of the onTimeout method because that timer is now gone. So let's go to generator and add the signal trigger. so that we generate gold. Generate gold when the timer times out. Cool. Maybe we can add a new signal, which will be saying that the generator was toggled. And we will give a boolean, which will be the is stopped. And we will give the is stopped value as a boolean when the toggle happens. So right there, the toggle generator thing, we will just simply generate a toggled signal. We will emit it and give as an argument timer.isStopped. That sounds and looks correct to me. All right, let's see. Now we can get rid of all those methods and actually get rid of this as well. And pretty much get rid of everything actually. Now we can just delete this script, have this button disconnect here, and just have each element be responsible for themselves. So the label here will have its own script. So we will check built-in and have label. All right, so it extends label. And we want to have the update script like this. And the text will be equal to gold, and gold being game.red.data.gold. So that's going to be the update. There's a problem. Yep, I forgot 1% here. Then, of course, we want to update this label when we are ready, before we get ready. And we want to create a connection to the manager so that when gold is created, well, actually, let's say gold updated, because maybe sometimes we will decrease the amount of gold. So when gold is updated, we want to update the text right there. So let's connect the signal by having manager gold dot ref dot gold created dot connect to on gold updated. Now that here we have this signal here has an argument. So as usual, we need to buffer this argument here by saying quantity int discarded, basically. All right. So here the label's done. Now the button. The button will have its own script as well. It's going to be button. And actually we just need to grab the signal from the button. So we will have on pressed. And when that happens, we want the manager generator to toggle the generator. All right. But also we do want to update the button. So let's create an update method. So that's going to be void. And here we want the text to be equal to the state, to be different based on the state of the button. So let's have this if is stopped. What we want to do if the generator is stopped, we want to say text equal generator off. Else, we want text to be equal to generator on. So here we need an argument is stopped, like this. And we can now create on generator toggled, which will take an is stopped argument. and call on the update method like this. So here update is stop. There we go. So now that we created this, we need on the ready method to connect the signal to our manager generator. So we have the signal generator toggled. We want to connect this to the on generator toggled, right? Then we have the argument and everything's fine. The little slight problem we have is when we start the game, what do we do exactly? We need to call the update, but we need an argument. So what we're going to do very simply is for update with manager generator dot ref dot is stopped. Is it? No, dot timer dot is stopped. That's, yeah. Let me see, do we have another method? Did we create a method that I forgot about? No. Let's just, for the sake of things being easier, let's have a is stopped method here, which returns a boolean, and that will return timer dot is stopped. So we can go in the button there, and instead of having to go in the timer, we can just go in the, have the is stop reference for the generator. Let me just check that we have the auto completion. Yep. Alrighty. So we changed a lot of things. Yep. So the label has moved, the button has moved, and all the logic is here. Oh, sorry, that must be a return. My big bug. Alright. What happens if I start the game? And if generator off, I can turn it on, and it doesn't show this because there's a reason for it. Let me see. We have the timer. Maybe it's in the label. Does the label update? Yep, the label updates when goals created. Okay. Here, goal created. Is it because it's not emitted? It is emitted. So let's see. Do we actually create goal? Let's use a breakpoint. Did I launch the wrong game? Probably. So when I generate on, yeah, there's no goal being generated here because the breakpoint is not summoned. So we can get rid of that breakpoint and go check in generator. That's probably there. So we generate gold. Oh, that's because we use this old method. So let's add the manager gold dot ref dot create gold quantity way of doing things. Sorry, quantity must be generator power. My brain's fading on me again. And let's go. So now we can turn on. That was a little bit long, was it? That's fine, actually. Okay. So that's it for the beginning of the generator. Now, let's simulate having a few upgrades, okay? So here in data, all we have to do is have a variable generator upgrade 01 level. That's going to be an int and it's going to be level 12. Then we will have generator upgrade 02 level. That's going to be an int and it will be level 8. And we will have generator efficiency upgrade 01 level int, and that will be equal to 3. Okay. These are the 3 upgrades we have right now. So now let's go back to the generator manager and create power increase based on those upgrades. So here, let's have this to be variable new power float. Now that's going to be int. Now let's get it to float at the moment. New power equal 1. This is actually what I did in PokerClicker, right? I did all the calculations with floats so that the small percentage can add up, add up, add up until it's an entire new unit. And I converted everything at the end into an int. So we're going to do the same here. So new power is equal to 1.0. First thing, we will add, let's say 5 for each. Do I have a data object? Well, now I do. OnReady var data dot data equal gain dot rate dot data. Cool. So here we said data dot generator upgrade. For each level, I will add 5 power. Then, for each level of the second one, I will add 10. So that's going to be data and the second upgrade. And I will multiply this by 1, and I will add 10% for each upgrade level, each efficiency upgrade level. All right, now that I have this, I will just have generator power to be equal to an int version of new power. All right. So this way, if I start the game now, we should have a way stronger generator. Oh yeah, way stronger. Okay. So now we can start playing with the timer, because the timer is kind of the heart of the generator. So maybe we can create an upgrade that will, change the speed of the timer. That could be interesting to have. So let's have a new upgrade, which is going to be generator efficiency upgrade 02. Right? And that's going to be an int as well, and that will be level 5. So now in there, I will create a new method that's going to be calculate generator, let me think, generator, let's say efficiency. So by default, I want the generator efficiency to be equal to 1, and that will be the time needed for the generator to basically generate things. So let's see. We need to create a variable to store this, of course. So that's going to be variable generator efficiency. So it's a little bit fuzzy what is efficiency, because it's been used a few times for different contexts. I'm sorry for that, but yeah. So yeah, the efficiency, we want it to be calculated, of course. So let me pass this and calculate generator efficiency. So by default, I want this to be equal to bar new efficiency. That's a float equal to 1. And I want to decrease this by, let's see, new efficiency minus equal 0.05 multiplied by data dot efficiency upgrade 2. And then have generator efficiency equal to new efficiency. Then what we will do is change the timer dot wait time to be equal to generator efficiency. Or do we actually want to have this in the update method? Now let's leave it there. If we start the game now, the generator should be faster, so it will be hard to see directly. So what we're going to do is just check in the remote, find the timer, and see what is the current wait time. So here, the timer is there. The wait time is 0.75 seconds. So it did decrease. That's cool. That's very cool. Okay. Now. We will tackle quite a big part, and it's already a long video, but let's make it longer. What we're gonna do, basically, is create a new timer node to implement new features. And the main feature I'm thinking about is fast forward, sort of. Speed up. Does it make sense? I want the game to go faster, you know, uh, 2 times faster, 4 times faster, and 8 times faster. So yeah, in the process of making this timer node, we will actually know how to create a generator through the process method. So let's see, how am I going to do this? I think I was taught by doing it from scratch. So let's create a new node and stop everything. A new node that I will call AdvancedTimer. Okay, in that AdvancedTimer node, I will save somewhere. So game, generator type managers, and let's have components. Components. And there we will have AdvancedTimer. Let's save this. Give it a script. All right. Let's name AdvancedTimer. So we need a few variables. Basically what we're going to do is recreate the timer node so that we can tweak things. Let's start by creating a few variables. So we'll create the variable isStopped, which is a Boolean. I will initialize it to true. And what I will do is I will use getters and setters because that's pretty much how the current timer works, right? If you think about the value is stopped, you can't grab and modify the variable. You can just get and set it. So here we will do the same by using a colon and have this set value. And if we do set is stopped, what we want to do is pass. Is it okay? Yeah. And get, when we get, we want to return is stopped. Okay, that sounds good. Let's have this column right there. What are the other variables we have? We have the wait time. So we have bar wait time, which is a float, which is by default equal to 1 second. And again, I will have a getter and setter because when we set the value, we change the value. What I want to do is stop the timer, change the value, and start it again. But at the moment, what we can do is change this. So we'll have wait time equal value, like this. And the get, we don't need to do anything because it's going to be the same, just getting the value here as well, right? But yeah. So let's have this function. Let's have this start and stopped method. So we can use those. 1, 2, 3. So function stop and pass as well. So right now, when we change the value, we want to stop, change the value, and start, like this. Okay. Let's look at the timer. If we scroll back to the top, we have the auto start and the one-shot booleans. So let's do this. AdvancedTimer. Let's see. We have variable auto start, which is boolean, default to false. Wait time is also an export value, by the way, because we can change it in the editor. Then we will have the export one shot. So we have one shot boolean and false. Okay. So if we look at the timer here, we have auto start, we have one shot, we have wait time. Okay. What else do we need? We have the paused, time left, right? There's this process callback thing. This is something that basically asks us, do you want the timer to work on the frames of the process or the physics process? We will assume that the timer here always work on the process and not the physics process, so I will completely ignore this one. It's already quite a complicated process we're going through right now. All right, so let's continue. We have the paused and time left values. So let's see. Let's create variable time left. So that's a float, which is by default equal to nothing. And we can set it. So set value will be plus. And actually, yeah, I think we don't need to have this getter right there. Let's have this like this. It should work. I don't know. I'm brand new to using getters and setters in Godot, so I might make mistakes. The next thing we need is post, and that's going to be a boolean, and we can set it and get it. That's okay. So by default, it's not going to be post. All right. So when we start this, what we want to do is have time left to be equal to wait time, like this. And when we stop, we want is stopped to be equal to true. And right there, we want is stopped to be equal to false. Nice. So now we need the timer to actually do things. So let's just create a signal, timeout signal, and let's create the process method because that's the most important one. So process delta void. Okay. Do we actually need something in ready before? Yes, we will need something in ready. Let's do that after. So here, we want to process to basically proceed to do what it has to do. If two conditions are checked, we do want to be sure that the timer is not stopped and it's not paused. So if it's either stopped or paused, we want to abort the mission. So here we will have this if is stopped or paused. So if the timer is stopped or paused, we want to return and just do nothing. Otherwise, we want delta, which is the time that the elapsed time since the last frame. We want time left to be deduced by delta, basically, like this. And then we want to check something. If time left is equal to 0, we want a timeout. So we don't have a timeout method. So let's create this function timeout, which is a void method, and at the moment it will pass. Well, it will emit the timeout signal. Okay, so it doesn't like the idea that there's the timeout method and signal having the same name, so I will just use an underscore. All right. In fact, I usually don't think too much about private and public properties, but maybe we can do this in this script. Maybe we can do that. Every private properties and methods will be underscored. All right. So here it's very basic at the moment. So when the timer times out, we want to emit the signal and we want to check something, which is it a one shot? So if one shot, so if, yeah, we're going to go with if one shot. If it is a one shot, we want to stop, and that's it. We just want to stop it. Else, we want time, we want to, at the moment, let's have time left equal wait time. All right. Let's do the ready method, because we didn't do anything for the ready method at the moment. So if auto starts, we want to, well, start. And otherwise, I guess we want to do nothing. So here, when we start, we set the time left, so that's cool. And yep. I think we're kind of good. Of course, there's quite a lot to do because this is very clumsy, right? It needs a lot of things. But maybe we just want to check that just this works fine at the moment. Well, there's a problem. Let's take care of the excess. Otherwise, we will have problems. I'm going to create a private variable, which is going to be time excess. I'll just name it excess at the moment. So the excess is basically if the frame takes longer than the time available in the timer, there will be an excess of time. So we will take care of this. So basically, if delta is superior to time left, we want delta minus time left to be stored in excess, like this. And there's an underscore. Otherwise, if this doesn't happen, we just want time left to be reduced by delta. And then we can check. So right now, delta should always reach a 0 spot. Because if delta is supposed to be negative, it will actually be forced to 0. I'm saying delta, but actually I'm talking about time left, really. Like this. Well, actually, let's not care about that. Well, these are floats, so let's compare them as floats. Okay. At the moment, we do nothing with the excess, and we will take care of the excess around there. Do we want to? No, we want to check that the timer works. So in the generator manager, basically, we will get rid of that timer right there, and instead bring our brand new timer that we created. It has a few things, so we have a wait time of 1, it's not a one shot, it's not an auto start, and here we will change the export variable to be timer to be an advanced timer, right? Why are you crying? Yep. So I will create this method in the advanced timer right now. So let's see. We will have the where is start. Let's go there. It's not gonna have a get, okay, but we will have a is stopped method. 1, 2, 3. Function is stopped, which will return a boolean, right? And we will return is stopped. And here, just put a few underscores. Okay, so now the manager will be happy. Cool. So we have this, and we now need to connect the signal. So we have timeout signal, and this will go in the script. Wait a second. Well, just, yeah, in this guy, connect. And here, remove that and generate gold there. Generate gold. Okay. Common parent is no. What does that mean? Because what? Then see in main node parameter common parent is no. There's no where's the red dots? That's weird. Anyway, let's try this. Here, wait time timer.waitTime equal generator efficiency with value of type float. Yes, what's the problem? Timer. Oh, didn't I set the timer? Oh, I didn't assign the timer. That's my bad. All right. Okay, so now we can start this. Did I click? Oh, it's when we set the value here. Okay, I get it. We need to check there. So if not is stopped, then we want to start. Well, actually, we need to know that before. Huh. So we're gonna go with if not is stopped. Or we can use the underscore. So if not is stopped, I will create a should restart boolean, which is going to be false. And if not is stopped, should restart will be true. And there I need a T to restart. Right. Then I stop, and if I should restart, I will start. Okay. So now it should be better, I guess. It's not supposed to be negative. This should never happen. Oh, that's because I didn't put that in an elf. That's my bad again. Yikes. Yikes, yikes. Okay. Now I don't need a breakpoint, thanks. And the timer is finally working. All right. What we can do, because right now what we did is just recreate the already existing timer. But what's the point, right? We can use the timer which already exists. The point is that we can now do things like working with this excess variable and modify how things are working. So let's start with the excess variable. The excess variable will be dealt with in a method which was going to be named, let's name this restart. Let's name this, yes, automatic restart. Let's auto restart. Yes, that's cool. Auto restart is going to be a void method. And basically, what's going to happen here, it's going to be start, right? So we want time left to be equal to wait time. But we want to check that the excess, basically, is inferior to the time left, right? So if the excess is superior, well, let's first, wait a second. Time left, we said we want this to be equal to wait time. After that, we want to check that excess is inferior to time left by checking if it's superior. It's kind of weird, but if it is superior, what's going to happen is that excess is going to be equal to excess minus time left. And we will want to auto restart again. Well, not necessarily, but we will want to have this, wait a second. Let's have this while excess is superior to time left. Let's do it like this. While excess is superior to time left, we'll have excess being deduced time left, like this, and we will time out. Dot limits. And then once it's finally, and at the end of this, obviously we want time left to be equal to wait time. So what I'm doing is, as long as we have more excess than we have time to wait, we're going to reduce that from the excess, emit the timeout method, and reset the timer again to check you will still have more access than timer. Until we don't, then we will have time left minus equal excess, and there we should be able to go. So here, when we time out, if it is a one shot, we stop. Otherwise, we auto restart like this. So right now, nothing should have changed, right? It should be exactly the same, except that the excess is counted, and that's a little bit cool because if you have a 0.012 seconds excess every seconds, well, over hours and hours and hours, you lose variables, no, resources. So that's why taking track of this excess, as small as it can be, will make your game more accurate. Okay, now for the last upgrade of this timer, we will create a new export value, which is going to be variable. I will name this time multiplier, speed multiplier. Yes, let's name it time speed. Or just speed. I think speed is fine on its own. That's going to be a float by default equal to 1.0. So here, that should appear right there, right? We have the speed. And what we will do, very simply, we will create a variable elapsed time, which is going to be a float, to be equal to delta multiplied by speed. And right now, every delta here must be elapsed time. Elapsed time and one last time. Okay. So now, again, it should work fine like this. All right. And we should be able to modify this value. Let's say have it 4, and that will generate gold much faster, like this. So now you can basically create 4 speed, 8 speed, etc., so that you can speed up the game, right? So now we have an advanced timer that can do this. This is the satisfaction we get for all the pain of rewriting the entire timer node. Anyway, there's definitely other things you can do, I guess. For the how to name this? You can try to have this kind of fast forward things where you have resources. You have how do I put that? Sometimes in a game you have this option that says skip 5 minutes, right? So what you can do basically is have this little thing, right, which says a little method right there, which would skip time. So maybe we can use excess for that. So let's see here. Excess, let's have excess plus equal elapsed time. And right there, time left minus excess. And here we will reset the excess. So the point here is that at any time, I guess, you could change the value of excess, okay? And that should fast forward the game. What's the problem? Standalone expression. Oh yes, sorry. Access equals 0. My big bad. So let's try to simulate this just to be trying thing. Let's see. Let's have this speed set to 1, right? And the wait time set to 10 seconds. Okay. Now in the generated prototype, in the generator manager, I will create a method which is going to be generate excess, like this. And I will actually create the exact same method in the timer. So here, we will have generate excess. Okay, it's good. So it's going to be a void that will do nothing, and we need time to be added to the excess. And yeah, excess is going to be plus equal time, like this. So now the manager should be able to have this timer.generate excess, and here we will have time dot float. Okay. So now that we have this, I can go in my prototype. I will create a new button, just because I want it to be a little bit fancier. I will have this in the bottom corner, and I will have a 16 pixels margin. And there, a new button, which will have 320 and 80 pixels, and there will be skip time. So now, in there, I can add a script, a built-in skip time button, like this. I'm gonna read skip time button. And I'm just gonna grab the signal, the pressed signal, like this. And now I can go in my manager, generator, and actually, yeah, here I will rename this skip time. Nice, way better. I can go in the script, manager generator dot ref dot skip time, and let's say that we skip 3000 seconds. Oh my god, I never tried what I'm doing, so it could be huge crash. I'm going totally random here. Okay. So I guess, oh, yes. I guess we need to force a check on the timer. So let's see if, that's gonna be a bit complicated, but where's the timer? It's here. Right there, we're at the time, and we need to basically pause the calculation. So the calculation is in the auto restart. How would I do that? Maybe the auto restart should be set differently. So here, the if one shot should be in this method instead. And that should not be named auto restart. That should be named excess dump. Let's go with the excess dump. So right there, we time out and we excess dump. Then, at the start of this, we will have if auto restart, no, if one shot, we want to stop, else if, so it's going to be an elif, not is stopped, right? If not is stopped, we want to start again. So we want to have this restart, auto restart here, auto restart. Timeless minus access. Yes, and here we should have this function auto restart. Do we? Do we actually need that function? Or will it just do nothing? Because, you know, here, if the timer is stopped, it will block there anyway. Okay, so maybe we can do this and have this access dump right after we click. So first, just to be sure that, let me see, let's have the timer set back to 1 to see if it is still working fine. Let's check that the timer works. Okay. Now I can stop it and skip time. Okay. That created something. And now I can start again and skip time while it's running, and that generates gold. Okay, well, phew, I'm absolutely exhausted. My brain is leaking through my ears. But yeah, we're done. We're finally done with this video. We did a lot of things, concluding very fast because somehow I'm very eager to be done with this. So anyway, that's it for this little introduction to intermediate generators for idle games. I hope you liked it because that was fun to make despite the little stumbles, I guess. Tumbles? No. Stuff. Anyway, hope you liked it, and I did. So, yeah, and I will see you in the next videos. And hopefully this one will be about, I think it's singleton I must make, which I told you to go visit. So anyway, I'll be making the next video, and you take care, and I'll see you later.